Now, they have asked one question. Listen to this. Right on. First question. And this is, you make a note also. It is page 13. Make a note in the module. It is page 13. It is concept application exercise 1. It is page 13. It is concept application exercise 1. In that, it is the fourth problem. Okay, make a note. So once you get your module, you can mark it. Okay. So it is page 13, concept application exercise 1, and it is question number 4. The question is, which of the following is forward biased and which of the following is reverse biased in this particular diagram? So they have given one diagram. This is the first diagram. And the next diagram is so this is the first diagram and this is the second diagram. Now you have to tell whether the first diagram is forward or reverse and the second is forward or reverse. Make a note of the question and then start and tell me the answer. For answering what is forward and reverse, you should know what is the definition of forward and reverse. Okay? Okay, give me the answers, whatever you feel. Switch on your cam, all of you. I'll start putting you out one by one. Okay, see the logic is, listen to the logic. This is plus 5 and this is grounded. This is a symbol of grounding. I hope you guys know. This is the symbol of grounding or this is the symbol of earthing. This is the symbol of grounding or this is the symbol of earthing. Now, if you have the symbol of earthing, that means it is zero potential. And this is plus 5 potential. Now tell me in 0 and plus 5, which is higher? Higher is plus 5. That means that is positive compared to 0. So that is positive compared to 0. So 0 is negative. So I'll repeat. Compare phi and grounding, which is higher. Can I say phi is higher? Therefore, phi is positive. Therefore, this will become positive and the grounding is lesser than phi. So grounding will become negative. So now positive is connected to negative of the diode and negative is connected to positive of the diode. Correct? Because this diode, in this diode, this is positive and this is negative. So when I say negative is connected to positive and positive is connected to negative, therefore the entire diode is reverse bias. Therefore, the first diode is reverse bias. Similarly, start with the next one and tell me whether the next diode is forward bias or reverse bias with the same logic. So the next diode, if you go to see, this is minus 10 volt and this is 0, correct? Because grounding is 0. So between minus 10 and 0, which is more positive? 0 is more positive between 0 and minus 10. Therefore, can I say 0 will get a positive sign and minus 10 will get a negative sign? 0 will get a positive sign and minus 10 will get a negative sign. So again, if you notice, this diode, positive is connected to negative and negative is connected to positive. That means positive is connected to negative and negative is connected to positive. So again, this diode is also reverse bias. So this is how you come to know what is a forward bias diode and what is a reverse bias diode. So this is also reverse biased and this is also reverse biased. Did you understand the question?
Sir, can you explain the second case again?
Second case, between minus 10 and 0, which is higher? Between minus 10 and 0, which is higher, or which is a higher value number? Minus 10 is a high value number or 0 is a high value number? Can I say 0 is higher compared to minus 10? Therefore, 0 is more positive compared to minus 10. Therefore, this will get positive and this will get. No, both cases are reverse. Later. Because over here negative is connected to positive and over here positive is connected to negative. So again, it is same like reverse bias. What is forward bias? Forward bias is when positive is connected to positive and negative is connected to negative. That case is forward bias. In this case, negative is connected to positive and positive is connected to negative. Therefore, it is reverse bias. Is it clear? All of you? Any doubt, please let me know. We'll do a similar question. The next question is similar to this, so you can get more practice. Okay? Right now, question number 5. Question number 5, the question is same. Which of the following diode is forward biased and reverse biased? So the first diode is start. This is question number 5. Same page, same concept application. You have to find out whether this is forward bias or this is reverse bias. Start. Okay. Nikhil correct, Lavnish correct, others try to answer. Soumya correct. Krish correct, title correct, good. Okay, I will start and then you guys figure it out. Okay, see this. This is plus 5 and this is plus 10. Which is higher? Plus 5 or plus 10? Can I say plus 10 is higher than plus 5? Therefore, can I say plus 10 will be given a positive sign and plus 5 will be given a negative sign. That means plus 10 is more positive than plus 5. So in this diode, plus 10 is given a positive sign and plus 5 is given a negative sign. Therefore, in this diode, positive is connected to positive and negative is connected to negative. Correct? Positive is connected to positive and negative is connected to negative. Therefore, this diode is a forward bias diode because a diode in which positive is connected to positive and negative is connected to negative is anyway a forward bias diode. Therefore, answer for this is forward bias. And many people gave me the right answer also. People, in fact, who have given me the right answer, I have told you their names. Now, next one. Start. Whether this is forward bias and whether this is reverse bias. Start. Okay, see this. This is minus 12 volt and this is minus 5 volt. Now, which is higher, minus 12 or minus 5? Which is having higher value? Can I say minus 5 is having a higher value? Therefore, minus 5 will be given the positive compared to minus 12. Therefore, this is negative. So, minus 5 is positive compared to minus 12. Therefore, this is positive and this is negative. Now, can I say this is also forward biased? Because positive is connected to positive and negative is connected to negative. Can I say that? Positive is connected to positive and negative is connected to negative. Therefore, even this is your forward bias. Even this is your forward bias. Understood this question, all of you? Now, next question is question number 9. Next question is question number 9, page number 14. Please make a note because when I ask you once you get the module, there are some questions which I am not doing because very lengthy. That once you get your module, will do. Okay. So I'll dictate the question right now. I'll dictate the question right now. A PN junction diode, I know, a PN junction diode, a PN junction diode, when forward biased, a PN junction diode, when forward biased, has a potential drop of 0.5 volt. Written, a PN junction diode when forward bias has a potential drop of 0.5 volt. Full stop. The current in excess of 10 milliampere, right on. The current in excess of 10 milliampere produces heat. The current in excess of 10 milliampere produces heat which damages the diode. Which damages the diode. Full stop. If we want to use a 1.5 volt battery, if we want to use a 1.5 volt battery to forward bias the diode, if we want to use a 1.5 volt battery to forward bias the diode, what should be the value of resistor? What should be the value of resistor so that what should be the value of resistor so that maximum current does not exceed 5 milliampere. So that the maximum current does not exceed 5 milliampere. Start. Give me the answer. I've got one answer. Let me see other answers. Okay, title it is correct. Others. It is very, very straightforward question. Okay, see here. Correct. So I know that V is equal to IR. Therefore, R is equal to V by I. Basic formula, Ohm's law. V is equal to IR. So R is equal to V by I. But over here, it will be delta V by I. It will be delta V by I. Now, it can be delta I also, if you go to see the logic, but it cannot be delta I because they have said that we need maximum current of 5 milliampere only. That means there is no doubt in the current. That means the current will be 5 milliampere itself, because read the question that the current should not exceed 5. That means I know my current is 5 and my potential 1.5 volt is applied potential and there is already a drop of 0.5. Therefore, potential difference can I say is 1. 1.5 minus 0.5 is 1. 1.5 minus 0.5 is 1. Therefore, can I write it as delta V is 1.5 minus 0.51. So R is equal to delta V by delta I or delta V by I, because I know that the current should not exceed 5. Therefore, I'll keep current as 5 itself. So if I do this operation, voltage upon current, tell me what is the answer I get for resistance. You will get the answer as 200 ohm. Check all of you. If you do the calculation. Do the calculation and let me know whether you're getting the answer as 200 ohm. All of you. Nikhil, correct. Good. Got it? Okay, let others also finish. Give me the answers, all of you completed. Okay, correct. Getting it? Let me check. Got it. Yes. Okay, last class, I had told you to leave a place for transistors, right? I told you I'll give you the symbol of a transistor, and I said that in the textbook we have given it a bit wrong. So I will give it now. So look at the symbol of a transistor. Now please first listen to me. Now tell me, how many types of transistor are there? There are two types of transistors. One is NPN transistor and one is PNP transistor. So first, let us do the symbol of NPN transistor. The symbol of NPN transistor, see this. This is emitter, this is base, and this is collector, and this is the arrow mark. And for PNP transistor, it is same. It is base, emitter, and collector. So for both, this is same. See here, emitter, base, collector. This is emitter, base, collector. The only thing that changes is the arrow mark. Here the arrow mark is going away from the base. Here the arrow mark is pointing towards the base. That is the only difference in the symbol. Now what does the arrow mark indicate? Arrow mark indicates the flow of holes. Arrow mark indicates the flow of holes. Therefore NPN transistor, it goes away. You can remember NPN as never points in, and PNP as points in permanently. Can you remember that way? For NPN, you can remember as never points in. For PNP, you can remember as points in permanently. So points in and never points in. But many times what students make a mistake is they write emitter, base, and collector. That is wrong. It is emitter, base, collector. So for NPN, it is the arrow mark is this, and for PNP, the arrow mark is this. So first draw the symbol of PNP, draw the symbol of NPN, and below that I'll give you one statement. Okay, start it. Start drawing. Once you finish, put a dot, then I'll give you one statement below. Finished? Below the diagram, write down. The arrow indicates the arrowhead. It is called the arrowhead. Write down. The arrowhead indicates the arrowhead indicates the direction of flow of holes. The arrowhead indicates the arrowhead indicates the direction of flow of holes. The arrowhead indicates the direction of flow of pulse. Clear? Next one I'm doing is page 22, concept application exercise 2. In that, question number 5. Make a note. Page 22, concept application exercise 2. In that, question number 5. Write down. A transistor has a current gain of 0.97. Write down. A transistor has a current gain of 0.97. Please make a note quick. A transistor has a current gain of 0.97. That means alpha is equal to 0.97 and base current is 0.12 milliampere. And base current is 0.12 milliampere. Calculate the collector and emitter current. Start. Calculate the collector and emitter current. This is the data given. Therefore, the current gain alpha is 0.97. IB, that is base current, is 0.12 milliampere. You have to find the other two. Start. I have written the answer also. Tell me if you are getting this. Nikhil is getting it. Others, let me know whether you're getting IC and IE values. Quick. Now tell me, what is alpha equal to actually? Alpha formula, what is alpha? IC by what? IE. Correct? Yes or no? Alpha is IC by IE. So tell me, alpha is given and IB is given. Now tell me, how do you proceed with this knowledge? How do you proceed with this knowledge?
So we got beta, right? IC upon IB, and IB value is given.
Okay, so this is one approach. Beta, I can write it as IC by IB. Anyone understood? Now, beta, I don't know. IC, I don't know. But IB, I know. Correct. But I know alpha. Can I get beta first? I know alpha. Can I get beta? Tell me, if I know alpha, what is the value of beta? Or what is beta in terms of alpha? Can I say beta is equal to alpha by 1 minus alpha? Is this formula correct that I've written on the screen? Just check.
Yes, sir.
So tell me, what is beta equal to from this formula?
0.97 by 0.03, around 32.
It is 0.97 divided by 1 minus 0.97. So tell me, what is the answer you get? So it will become 0.97 divided by 0.03. Correct?
3.23.
How much?
3.23.
3.23, no, 32.3.
32 point.
Because it will become 97 by 3. Correct? 97 by 3 is 32.3. Therefore, can I say beta will become 32.33 or it will become 32.33 or 32.3. So now I know the value of beta. I also know the value of IB. Can I get the value of IC? Check. So IC is equal to beta into IB. IC is equal to beta into IB. What is IB? 0.12 milliampere. So tell me, what will be the answer? 32.33 into 0.12. Can I say that will be nothing but 3.88 milliampere? Exact. 32.33 into 0.12 will be 3.88. Therefore, can I say IC is 3.88, IB is 0.12. Therefore, IE, can I use the basic equation of a transistor that IE is equal to IC plus IB? The most basic equation of a transistor is IE is equal to IC plus IB, which is nothing but 0.12 plus 3.88, which is 4 milliampere. Therefore, answer is 4 milliampere. Check whether you're getting it. All of you. Oh, that is fine. But the logic is right, right? Okay. Now, next, I'm not doing the problems which are lengthy for you to write. So just make a note of whatever problems I'm doing like this. So once you get the book, let me know that this is done. Others I'll have to do. Now, the next question that I'm doing is page 28. Make a note. Next question I'm doing is page 28. Concept application exercise 3. Page 28, concept application exercise 3. In that third question, I'm doing the third question. And the question is, produce the truth table for the following circuit. Produce the truth table for the following circuit. Start. Means A, B, and Y, you have to produce the truth table. Means A, B, and Y, input and output. 0, 0, 0, 1, 1, 0, 1, 1. So title, tell me which gate is it? Looking at the output of the truth table, tell me which gate do you get? Got it? Okay, I will do it. Tell me if you get it. So first input is 0, 0, correct? Now 0, 0 of AND gate would be 0, but since it's a NAND gate, it would be 1. Similarly, 0, 0 of an OR gate would be 0, but since of a NOR gate, it will be 1. 1 and 1 of an AND gate would be 1, but since it's a NAND gate, can I say it will be 0? Therefore, can I say output here is 0? Tell me if you have any doubt in this. This is clear? Okay. Next one. 0, 1. Correct? Next one is 0, 1. So 0, 1 over here. AND gate would still be 0, but this will be 1. So I will take it as 1 over here. 0, 1 OR gate would be 1, but NOR gate would be 0. 1 and 0 AND gate would be 0, but it's NAND gate, so the population inversion takes place. So it is 1. Or this much. Now, the next concept is 1 and 0. 1 and 0 for AND gate would still be 0, but since it's a NAND gate, it is 1. 1 and 0 for an OR gate would be 1, but since it's NOR gate, it is 0. 1 and 0 for an AND gate would be 0. This would be 1 because it is a NAND gate. Therefore, answer is 1. Now I will take the last one, that is 1, 1. So I'll take last one, that is 1, 1 and 1, 1. 1, 1 for a AND gate would be 1, NAND gate would be 0. 1, 1 for a OR gate also would be 1, but NOR gate would be 0. 0, 0 for a AND gate would be 0, but NAND gate would be 1. Therefore, my answer is 0, 1, 1, 1. Tell me, are you getting it? Yeah, Krish, your equation was your homework, right, Krish? And the graph
Sir, I've
was.
done two. But
So once I
are
get
you
the
going to
module, I
explain
will
it?
show it to you. In the module, I'll show it.
Okay. Okay.
Krish. Now tell me, all of you, looking at the truth table, which gate does it symbolize? Which gate does it symbolize? It symbolizes, can I say, OR gate. It symbolizes OR gate. Therefore, in the question, what they will tell you is, what does this particular circuit symbolize? Which gate? AND, OR, NAND, NOR. So you have to do this truth table and get the answer. This is anyway page 28, concept application exercise 3, third one. Getting it? Okay. We will do one more from the same exercise. Okay. The question is, the input A and B is fed to a NAND gate. Draw the output. This is the question given. This is A and this is B. Now, instead of giving you 0, 0, 0, 1, 1, 0, they are giving you a waveform. Okay, this is question number 6. This is nothing but question number, not 6, this is question number 8, page 29, concept application exercise 3. This is the question. Now, they are saying that this graph is fed to a NAND gate. What will be the graph of the output? What will be the graph of the output? What will be the graph of the output? Start. Now, I will tell you the logic. If you're getting the logic, let me know, or else I will give you the logic. Okay, start. This is the graph. Graph of A and graph of B. Start.
Sir, can you repeat that NAND gate wala part?
So this graph is fed to a NAND gate. I have to draw the output graph. So how will the output graph come when I put this in a NAND gate? That is the question. So, okay, I'll tell you. It's a simple logic. If you're not understanding the graph, see this. This will be 1, 1 because both are high graph. This will be 0, 0 because both are low graph. This will be 0, 1, low and high. This will be 1 and 0. This will be 1 and 1. This will be 0 and 0. This will be 0 and 1. Lower graph is 0, upper graph is 1. Did you understand? So instead of giving 0, 0, 0, 1, 1, 0, they have given higher graph and lower graph. Now tell me what will happen to NAND gate if I give input 1 and 1. AND gate would be 0. So can I say NAND gate would be, sorry, AND gate would be 1, 1 and 1. So NAND gate would be 0. Therefore, my answer will be 0 here. Now, the next one is 0 and 0. 0 and 0 for AND gate would be 0. But can I say for a NAND gate, it will be 1. Therefore, for the next one, output will be 1. Did you understand how to do this kind of problem? Now, next one is 0 and 1. 0 and 1 for AND gate would be 0. But for a NAND gate would be 1 itself. For a NAND gate, it would be 1 itself. Now, 1 and 0 again for a AND gate would be 0. For an AND gate, it will be 1. 1 and 1 for an AND gate will be 1. Therefore, for a NAND gate will be 0. And 0 and 0 for AND gate will be 0. For NAND gate will be 1. And 0 and 1 for an AND gate is 0. For an AND gate, it will be 1. Therefore, your final graph will be like this. Are you getting this graph? Easy. This is how you get the graph problem. This is nothing but pulse. Low pulse and high pulse. Low pulse is denoted by 0 and higher pulse is denoted by 1. Low pulse is denoted by 0 and higher pulse is denoted by 1. Okay. Now the last question from here, so that the module, whatever I could give you, I will give it to you now. Okay. Now this graph is fed to OR gate. Draw the output. This graph is fed to OR gate. Draw the output. This is A and this is B. Get the output of OR gate. Start. Get the output of OR gate. Okay, we'll start with the output of OR gate. Now this is 0, 1, 0, 1, 0. This is also 0, 1, 0, 1, 0. Correct? So now what you have to do is get the output. 0, 0, answer of OR will be 0. 1, 1, answer will be 1. Again 0, 0, answer will be 0. 1, 1, answer will be 1. Again 0, 0, answer will be 0. Therefore, you will also get 0, 1, 0, 1, 0. So can I say output is the same as input? Therefore, can I say A, B, Y? All have the same pattern. Check. Input A, input B, and Y all have the same pattern. That is why in the exam, sometimes instead of giving you the truth table, 0, 0, 0, 1, 1, 0, 1, 1, they will give you the graph like this. So from the graph, you can make the truth table and then you can get the answer. Because you're not in JEE, you will not be asked to draw the graph. You can draw the graph on your own and get the answer outside. Therefore, you should know how to draw the truth table from the graph. So I'll give you one random graph and that graph is applied to a NOR gate. You give me the output. Try to draw the output pattern. Okay. So these pulses are fed to a NOR gate. Get the output pulse. These pulses are fed to a NOR gate. Get the output pulse. Yeah, right. When we meet in person, I can help you. Okay, Krish, that is good. Okay, now listen. If I go to draw, this will be 0, 1, 1, 1, 0, 1. And this will be 1, 0, 0, 1, 0, 1. Correct? So now NOR gate is the correct. Now the best way to do it is OR gate. 0 and 1 OR gate would be 1. So NOR gate would be 0. 1 and 0 OR gate would be 1. NOR gate will be 0. Same thing over here. 1 and 1 OR gate would be 1. Correct? NOR gate would be 0. 0 and 0 OR gate would be 0. NOR gate would be 1. And 1 OR gate would be 1. So NOR gate will be 0. So if I have to draw the graph, it will be 0, 0, 0, 0, 1 and 0. Are you getting this answer? So this is how you get the pulse. These are called the pulse problems or the graph problem. Therefore, instead of giving the truth table, they will give you the graph like this. They can give you any step function. I hope you can get the answer. It is very simple. In fact, this is more simple than the truth table because you can directly get it one below the other. Is it fine? Okay. Now, more on this I will do after we get the book. So please ask your whoever, Kanjali and Theri, to get just one book, electronic devices. If not, at least get the PDF of that soft copy. Okay, so that next class I can take a longer class because without the PDF doesn't make sense me dictating the questions to you. Okay? So please get the book next time. Also, tell me where you present in any of my communication systems classes in 11th standard, electromagnetic waves and communication system, where you present as a part of that class, where we did ground wave propagation, space wave propagation, sky wave propagation, where you are part?
I was there.
You are not a part of communication system at all of you?
No, sir.
Okay. Okay. So once you get your module, we will do that as well. Because if you look at the module name, it is electronic devices and communication system, where electronic devices is semiconductors and communication system is communication system. Means 2 chapters in 1. There are 2 chapters in. Is it fine? So let me know. Once you get the module, we will do that in the next class. Correct. Corrected. Fine, all of you. So we will continue in the next class. Make sure you have the module. Then.
Sir, I have a request. Sir, can you teach the resistor thing which has 3 or 4 bands and there's a multiplier?
I've already done that, right? Color code of a resistor, right?
Yes, color code. So
I've already done it, right?
I think I was not there for that lecture.
I will do it. I will. Remind me in the next class. At the end, I
Sir,
will do it for you.
can you? Okay, sir, because I have a test on that today and I don't know how to do that.
You have a test on that today. Okay, you stay back. I will teach you. Others can log off.
Hi, sir, thank you.
If you want to know the color code, you can stay back, all of you. I am going to teach. Okay. This one, right?
Yes, sir.
So this one, first you should know the table. Okay, this table you should know by heart. How will you know the table by heart? I hope you know the logic, correct, of the table. Do you know, all of you?
Yes, sir.
Okay. So B.B. Roy of Great Britain had a very good wife wearing gold and silver necklace, correct? This is your first column. This is your first digit, second digit. First digit and second digit is same, 0 to 9 and 0 to 9, correct? Multiplier is same, into 10 power 0 till into 10 power 9. But it goes 2 more steps, into 10 power minus 1 into 10 power minus 2. And tolerance, these two you don't need to learn. Tolerance directly starts from gold. What is gold? Hi-fi, correct? Gold is hi-fi, therefore gold starts from 5 into 2, 10 into 2, 20. So tell me if you know the table or do you need shortcuts to remember the table, all of you who are here. Can you manage the table?
Yes, sir.
Sir, you had taught that, right? Baby Roy wala.
Which one?
Baby Roy wala. So we remember
BB
it
Roy,
that way.
correct. This is BB Roy. But BB Roy will only give you the first column. We have other columns also, correct? Now, please look at the heading of the columns. Colors, first digit, second digit, multiplier, and tolerance. So whenever you're given a resistance, you will have 4 colors, correct? You will have 4 colors. Always remember that 3 colors will be together and the 4th color will be a separate color. The first 3 colors will be together and the 4th color will be a separate color. Okay, all of you. That means the first 3 colors will give you resistance and the last color will give you tolerance. That means the last color is independent of the first 3 colors. The last color is independent of the first 3 colors. Now look at the color band. The first band is called first digit. The second band is called second digit. The third band is called multiplier. And the fourth band is called tolerance. If you notice, all these are the headings of your table. First digit, second digit, multiplier, and tolerance. Check. First digit, second digit, multiplier, and tolerance are the headings of your table. Check. Easy? Now, you have to remember this diagram the same way. First digit, second digit, multiplier, and tolerance. Now, for example, they give you a resistor with the color blue, green, red, and gold. Okay. The first thing you should do is you should separate the first 3 colors and the last color. Look at the screen, everyone. The first thing you should do is you need to separate the first 3 colors with the last color. Now, last color will give you the tolerance. Now, tell me, what is the tolerance of gold? Tolerance of gold is plus or minus 5%. So, one part of your answer is over because we will need to find resistance and we will need to find tolerance. Therefore, first part of your answer is over, that the resistance or the tolerance of gold is plus or minus 5%. Now, see here, first digit is blue. So tell me, under blue, what is the first digit? Can I say first digit under blue is 6? Therefore, write 6 as it is. Now, the second digit is green. Now, tell me what is second digit under green? Under green, the second digit is 5. Therefore, you have to write 5. Now, red is my multiplier. Now, check what is the multiplier for red into 10 power 2. Therefore, I will write into 10 power 2. That's it. So, for this is your resistance. 65 into 10 power 2 ohm with the tolerance of plus or minus 5%. It is 65 into 10 power 2 ohm with the tolerance of plus or minus 5%. Is this much clear? So we will do one more problem like this. Okay. Brown, white, gray, silver. So now what I'll do is I will divide the first 3 color and the last color. Last color will give me the tolerance. So what is the tolerance of silver? Tolerance of silver is plus or minus 10%. So brown is the first digit, correct? Brown is the first digit. So under brown, see the first digit. Under brown, the first digit is 1. Therefore, can I say this is 1? Next, white is my second digit. Therefore, white, what is the second digit under white? 9. Therefore, I will write it as 9. Now, my multiplier is gray. So, under gray, check the multiplier. Can I say it is into 10 power 8? So, write it next to it. Into 10 power 8. Over. Therefore, answer is 19 into 10 power 8 ohm with the tolerance of plus or minus 10%. This will give you 1 mark and this will give you 1 mark, totally 2 marks. So tolerance is very, very easy. Gold is 5, silver is 10 and no color is 20. How do you get it? 5, 10, 20. That is 5 into 2, 10, 10 into 2, 20. Yes, Titan, tell me.
Sir, like this.
Hmm? Your voice, you're on mute. You're on mute.
Hello, sir.
Now I can hear you.
Sir, these resistance values are in like whole numbers. There are some resistance values like 1 point something, 2 point something. So can
I'll
they
tell
be
you why it will come decimal. It will be whole value. For example, 19 into 10 power 8 can be written as 1.9 into 10 power 7. Correct? So that way you get decimal. Otherwise, you get whole number. Only when you shift the decimal point here and there, you will get a decimal. Otherwise, always you will get whole numbers.
got it, sir?
Guys, want one more? And then we'll stop.
No, sir, I understood.
Understood? Okay, there are
Yes.
questions in the textbook also. We'll do one from the textbook. Yellow, violet, orange, gold. Do this. Yellow, violet, orange, and gold. Yellow, violet, orange, and gold. So here what you need to do is, again, you need to split. Gold is plus or minus 5% again. Gold is plus or minus 5%. Now, first digit is yellow. Therefore, first digit is yellow. That means yellow first digit is 4. Therefore, this will be 4. Second digit is violet. Therefore, violet second digit is 7. Therefore, this is 7. Multiplier is orange. Orange multiplier is into 10 power 3. Therefore, it is into 10 power 3 ohm. Therefore, answer is 47 into 10 power 3 ohm with a tolerance of plus or minus 5%. But some people also write it as 47 kilo ohm because into 10 power 3 means kilo. Is it clear? Easy? Okay, this is how you get the answers. Understood? Okay. Yeah, I'll look at it and I'll get back. Okay. So with that, I'll see it. Okay. Okay,
Thank you,
fine.
sir.
So with that, we'll stop for today. So thank you, everyone. Bye-bye.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye-bye.